7. Geography. Chapter 3. Tides. Tides. Can you tell? Observe the following pictures. Answer the questions given below and discuss. Do the above photographs show the same place or different places? Observe and note the spread of water seen in both the photographs. What is this natural event called? Geographical explanation. Both the photographs show the same place. If you stay near the coast for some time, you will realize that the sea water is sometimes very close to the coast, while at other times it is far away from the coast. We call these movements of the sea water tides. Barring a few exceptions, all the coasts on the earth experience tides. High and low tides are natural phenomena. Let us try to understand the scientific reason behind these natural events. Tides are movements of sea water occurring daily and regularly. The level of sea water changes after a specified period of time. After every 12 hours and 25 minutes, a cycle of high tide and low tide gets completed. This regularly occurring event appears to be quite simple and natural. However, it is directly related to the sun, the moon, and the earth, and the gravitational and centrifugal forces that interact between them. Try this. Keep a small stone or a chalk piece on your notebook and move the notebook from left to right with some force. Take water in a small container which has a handle. See what happens if the container is whirled around with force. Fill the mixer jars with water and switch on the mixer. Observe. Do this under the supervision of parents. Observe a fan and a slingshot while they are moving. Take half a glass of water. Slowly move the glass in one direction, in circular fashion. Observe what happens to the water. Observe what happens if you whirl a key ring around a finger. Can you tell? On the basis of the questions given below, discuss the results of the activities listed above. In which direction did the piece of chalk fall? Where did the water in the glass show a bulge? What effects did the movement have on the rings attached to the keyring? What happened to the water in the container and the mixer? Which forces could be operating in activities listed above? In which activities did you find that the centrifugal or gravitational force was greater? Geographical explanation. In all the above activities, the effect of the centrifugal force is visible. The centrifugal force acts in the direction opposite to the gravitational force. Centrifugal means going away from the center. You must have experienced it too. At the local fairs, if you sit in a Ferris wheel, your seat spins and leans outward away from the wheel. This also is an effect of centrifugal force. Divide the students into two equal teams. Conduct a game of tug-of-war for 5 minutes. Discuss their experiences in the class. Centrifugal and gravitational force. Due to its rotation, the earth gets a type of power or force. This force works away from the center. It is called centrifugal force. Due to this force, any object on the earth would be thrown into the space. However, the gravitational force is working towards the center of the earth at the same time. This force is many times greater than the centrifugal force. Hence, any object on the surface of the earth remains at the place where it exists. Tides. The following factors are responsible for the occurrence of tides: the gravitational pull of the moon and the sun, as well as that of the earth, revolution of the earth around the sun, and the indirect revolution of the moon around the sun, centrifugal force generated due to the rotation of the earth. The moon is closer to the earth than the sun, hence its gravitational force becomes more effective than that of the sun. Tides occur due to the relative positions of the moon, the sun, and the earth. A place on the earth located at the opposite point of the place experiencing high or low tide also experiences high or low tide respectively at the same time. This is a result of the centrifugal force. And try to understand the locations of high and low tides on the earth. When there is a high tide at 0° meridian, the 180° meridian also experiences high tide. The meridians that are at right angles to those having high tide will experience low tide at the same time. If it is a high tide at 0° and 180° meridians, then at which meridians will low tide occur? Think about it. Large rockets are used to go into the space away from the earth. Which force do they act against? Types of tides. As the timing of the tide varies every day, the range of a tide also keeps on changing. Generally, the highest tide occurs on full moon and new moon days, whereas on the days of the first and the third quarter, the high tide is at its minimum. Spring tides and neap tides are the two types of tides. Spring tide. On new moon and full moon days, the gravitational pull of the sun and the moon act in the same direction. Due to this, the total pull increases. Hence, the tide on these days is much higher than the average high tide. This is known as spring tide. As the bulge at the high tide is greater, the water at low tide recedes much more. The water level during spring tide is higher than the average high tides and lower than the average low. Neap tide. While revolving around the earth, the moon makes a right angle with respect to the earth and the sun twice a month. This position occurs on the first and the third quarter of each month. On both these days, the forces of both the sun and the moon operate at right angles on the earth. At the places where the sun causes high tide, the gravitational pull of the moon, which is at right angles, also acts on the sea water. Due to such conditions, the water level rise is less than usual at the time of high tide. Similarly, fall in water level is less than usual at the time of low tide. This is because the attraction of the sun and the moon are not complementary, but at right angles to each other. Such tides are called neap tides. Neap tides are a little lower than the average high tides and a little higher than the average low tides. Do you know? Intertidal range. The difference in the water level of the high tide and the low tide is called tidal range. In open seas, this range is about 30 centimeters. However, towards the coastal areas, it goes on increasing. Along the coast of peninsular India, the range is around 100 to 150 centimeters for most of the part. The highest tidal range in the world is observed at the Bay of Fundy along the Atlantic coast of North America. Here, the tidal range is about 1,600 centimeters. In India, the highest tidal range is in the Gulf of Khambhat. It is about 1,100 centimeters.